Okay, sorry for the loud. Okay, input production function. As I said, the cost of production is going to be introduced to you. Are you following the slides?
Yes, sir.
Okay. Today, oh, sorry. You are seeing, today I'm going to introduce you the other side of the economics, the supply side of the economics. Up to date, we exercise the consumer demand there. And now I'm going to introduce you the supply side. Okay, it is recording also. Okay. In the supply process, people first offer their factors of production to the market. As you are understanding, production operation process is important with the factors of production. Who are the households owner of these factors, such as input, capital, labor, so employee, and these are the important part of the production operation process. And the firms are renting, hiring, also paying some interest for getting this capital, paying some wages for getting these people as an employee. And this is the important part of the production operation process. And the factors are transformed by firms into goods, as you are understanding, and services, and offered to the consumers for their consumption. Production is the name given to that transformation of factors into goods. The firms is an economic institution that transforms factors of production into consumer goods. It organizes factors of production, produces goods and services, sells, produce goods and services. The firms and the markets, firms are the production and the organization that translate factors of production into the consumer goods. The role of the firms in the supply process, people offer their factors of production such as land, labor, capital, physical capital, natural resources into the production operation process, and they will then get some payments for this. This is the income of these people, wages, salaries, and firms transform the factors into goods for the consumers. Production is the transformation of factors into goods, and ultimately all supply comes from individuals because control the factors of production. A firm is an economic organization and economic institution that transforms factors of production to goods and services. It's organized factors of production, produce goods and services, and sell, produce goods and services. A virtual firm organizes production and subcontracts out of works. Many of the organizational structures of business are being separated from the production process. A virtual firm only organizes production, and virtual firms subcontract out of work. More and more of the organizational structure of business is being separated from this business. The goal firm is to maximize profit, and when you are looking to this equation, profit is the total revenue minus total cost, and the profit is then, of course, P multiplied Q is the amount of the total revenue is going to be subtracted from labor multiplied with wages plus real interest rate multiplied with the capital. When you are getting this all, then you will get the profit, of course. And if the total revenue is much more than the total cost, this will create some profit for the firm. For economists, total cost is explicit payments to the factors of production plus the opportunity cost of the factors provided by the owners of the firm. For economists, total revenue is the amount a firm receives for selling its product or service plus any increase in the value of the asset owned by the firm. As you are observing here, the production cost is given here totally, which is going to be introduced to you step by step. But let's just quickly flash to your introduction the amount of the total and the average variable and the marginal revenue, marginal cost, everything which is going to be given on the one graph to you. I will give you detailed information in the following slides, but let's look up on this just for being able to understand how the firm is going to profit maximize regarding to the profit, so-called cost minus or profit minus or the total revenue minus total cost, which is going to offer some profit. As you are observing here, this is U-shaped curve is the marginal cost, and this is the upper one is the average total cost, and in the mid is the average variable cost, and this is then the which is intersect all is marginal revenue, and there is also below somewhere else the fixed cost also, which is going to add it to the average total cost. Here it is assumed that the marginal revenue and marginal cost is satisfied, as you are observing here at point H or H is satisfied, then the profit maximization is verified. This is also illustrated in the above diagram. Profit maximization occurs at the most significant gap or the biggest difference between the total revenue and the total cost. As it is indicated here, it is probably the point H or the point hash, where it is indicates the total difference between the marginal cost and the, of course, marginal average variable cost, which is going to be very deep down, and the marginal cost and marginal revenue where it is intersect, and it is supposed and this is then the satisfaction for the firm for the profit. To maximize profit or minimize losses, the firm will produce point E units at point A. As it is indicated here, point A is here and point E is here. As I said to you, it is an intersection of disease. Then this profit will then indicate it total revenue minus total cost, which is then T multiplied Q. If then total cost is not separated to the wages, labor, and capital and interest, then you may write here then total fixed cost plus total variable cost, which is the total cost is going to be subtracted from the total revenue. Therefore, in the below diagram and the below equation is also written as P multiplied Q, which is the amount of the produced goods will be multiplied with the price of these goods, which gives us the total revenue, and we're gonna subtract it from the labor wages plus real interest rate multiplied with capital. And when we go to the next slide, the isoquant line or the isoquant curve is important to know before going to the calculations. And isoquant line, as you are in this illustrated here, it is a two-dimensional graph again illustrated, and the slope is given again here, the P labor divided to P capital. And isoquant line is a graph showing various possible combinations of inputs, labor, and capital that can be purchased for an estimated total cost. Any combination of inputs on an isoquant line provides the same total cost for the output. As you are observing here, either you're going to choose any of these points at point 8 to point 12, where it is going to be combined with 6 to 2 or 4 to 6 or 2 to 8, some or 9, will gives us this similar combination of this product, the capital and labor, which is going to be used and produced. Therefore, any combination of this capital and labor, which is going to be mixed and produce any X or Y product, will gives us the similar, let's say, cost. The ISO cost line is a graph showing various possible combination of inputs, as I have read before, that can be purchased for an estimated total cost. It can be any line, as I mentioned. The isoquant and isocost together, when we are going to introduce, isoquant shows all combination, as I said, of factors that produce a certain output, as in the former example, isocost, and isoquant is then the similar of which is combining now the capital and labor, which is going to parallel to the isocost curves. When the isocost curves and isoquant curves tangent to each other, this will then gives us probably the best possible combination. The isoquant shows all combination of factors that produce a certain output, as I said, and isocost shows all combination of factors that cost the same amount, as I have mentioned in the former graph here. Therefore, the cost and the combination of the factors, which is, it can be diversified and differentiate by capital to labor, can be in the mixed, different mixture can be used for creating any X product. Then this will then gives us some isoquant and isocost, let's say, shows the optimal combination of factors of production to produce the maximum output at minimum cost if it is tangent to each other. And isoquant, oops, it goes sometimes, I don't know. Okay. And isoquant is usually shaped concave because of the love of the diminishing returns with fixed capital. Employing extra workers gives a declining increase in the marginal product. As it is represented here, marginal rate of substitution is, or marginal rate of return is going to be represented with delta K or delta L, which is the differentiation of the capital to labor. The isoquant and isocost curves now together is combined each other. And as you see at the point where, at the red point where it is intersect the isoquant curve, the isocost, where the 4,000 some units is produced or combination used, then will gives us the maximum output, which is the total cost estimated 400,000 pound, or let's say here is pound, but can be a unit. If we're going to give an example, the wage is supposed to be 10 per hour and the rent is supposed to be $20 per hour, then the solution is a cost line for total cost 1,000 is supposed to be. The example is actually combined with the solution. Therefore, you don't have to worry about it. Is all the combination with L and K, which is labor and capital, then will be represented in the equation 10 plus L plus 10 multiplied L plus 20 multiplied K will then equal to total cost, which is 1,000 unit or 1,000 pound. Therefore, you can use either you can represent it either in terms K or in terms L. Here we represent it with K, and it is then 50 minus 0.5 L. Therefore, the equation is estimated for the cost equation for this given, let's say, parameter or the data. Another example, if you are going to give, suppose a firm needs 10 workers and one machine to produce a single unit. What is the production function? The wage is 5 and the rent is 100. What is the cost of producing 50 units? What is the cost of cost function? The solution again here, we're going to produce first the factors of production or the production function, which is represented with K and L. And here it is supposed to be minimize the cost where 0.1 L is going to be used with the K for producing, let's say, any unit of product. And when we are looking to the solution, to produce 50 units, we need 50 machines and 500 workers regarding to the given data. And when we're going to put the equation in a given formula, the total cost will be then multiplied with the 5 times 10 and 100 times 1. Then total cost will be then 550 plus 100 for a single unit. Then for Q 50 units, then 50 times the above given equation will be used, and this is then total cost is equal to 50 times 50 plus 50 times 100, and this will then make 7,500 for the given data. Then we're going to represent this with the Q, with the quantity. Then total cost, as you are represented, as you are observing, it is 10Q because it is so labor from the labor the participants, and the capital is then Q only. Then when we are going to put into the equation, then total cost is going to be wages multiplied with labor because of the amount of the labor is the cost with the amount of the wages will be then multiplied again with the capital and the amount or the cost of the capital, which is the interest, is going to be equal to 5 times 10Q plus 100 times Q because of this given example information above. Then this will then makes 150Q, which has meant 150 times 50. Then this will then gives you again 7,500 for this information for satisfying the given information is going to be verified. Firms maximize profit. Economists and accountants measure profit differently. Accountants focus on explicit costs and revenues, and explicit costs are out-of-pocket costs, that is payment that are actually made. Wages that a firm pays its employee or rent that a firm pays for its office are explicit costs. Implicit cost, opportunity cost of resources already owned by the firms and used in businesses. For example, expanding a factory onto land already owned. The accounting profit is going to be then explicit revenue minus explicit cost. The economists focus on both explicit and implicit cost and revenue. Economic profit then explicit and implicit revenue minus explicit and implicit cost, which then gives you the profit. The production function, the production process can be divided into long run and the short run, as I mentioned to you every time. The short run, firm constraint in regard to what production decisions it make or it can make. Some inputs are fixed. At least one unit or one parameter is supposed to be constant. And in the long run, a firm choose from all possible production techniques, and all inputs are assumed to be not constant, is variable, is changing, is dynamically activating and changing. The terms long run and the short run do not necessarily refer to specific period of time, but to the flexibility the firm has in changing the level of output. In macroeconomics, short run, where one factor of production, example, capital, is fixed, this is a time period of fewer than for 6 months to 1 year. The short run is generally defined as the time horizon over which the wages and prices of other inputs to production are sticky or inflexible. As I mentioned to you, at this one variable is going to be stable and constant. Very long run or long run, where all factors of production are variable, are changing, and additional factors outside the control of the firm can change, such as technology, government policy, or the expenditures and export importations, or some capital payments, or some interest rates. These things are going to be changed, or some wages, some salaries, everything. The long run is defined as the period of time over which these input prices have time to adjust. More specifically, in microeconomics, there are no fixed factors of production in the long run, and there is enough time to adjust. So there are no constraints preventing changing the output level by changing the capital stock or by entering or leaving in industry. In economics, the long run is the theoretical concept in which all markets are in equilibrium and all part prices and quantities have fully adjusted and are in equilibrium. This contrasts with the short run, where some factors are variable dependent on the quantity produced and others are fixed, paid ones, as I mentioned, and constraining entry or exit from an industry. Constraint means restriction, limitations. The long run contrasts with the short run, in which there are some constraints and markets restrictions, as I said to you, and markets are not fully in equilibrium. Production table and production functions. Firm combine factors of production to produce goods and services. A production table is a table showing the output resulting from various combinations of factors of production or inputs. Real world production tables are complicated. The analysis will concentrate on short run production when in which one of the factors is fixed. Sorry. Okay. Production tables and production function. Production tables show the output resulting from various combinations of factors of production or inputs. A marginal product is the additional output that will be forthcoming from an additional worker, other inputs remaining constant. The average product or average product, usually abbreviated as AP, is found by dividing total product by the quantity of the variable input, which is TQ over L or Q, average product. The average product is equal to total product divided to variable input, as I mentioned to you. It is the total quantity produced divided either labor or the capital. The production tables or the function is represented as it is observed here. This is then the, as you observe, here is the output, and here either capital or labor. Here is represented the capital. As you see, as much as you are increasing the capital, the output is not going to enlarge. It is increasing, but decreasing amount of increase realized, as it is mentioned in the former examples. And production function, a curve that describes the relationship between the input or factors of production and the output, and marginal product, change in production and change in output, and average product, the total production divided to input use. As it is represented here, the marginal product is going to intersect the average product at point where the total product is going to reach probably the optimal points. At that point, and it is going to decrease. It is increasing amount of decrease, but this is probably the best possible option, as it is represented here, the average production, which is going to become to the optimal, and the marginal production is intersecting it from the optimal or maximum points. The production table and the production functions. The production function tells the maximum amount of output that can be derived from a given number of input. Optimal input usage rule, one input case when price of product $2 and labor cost $10. As it is indicated here, the labor unit is given 1, 2, 3, 4, and the total production is given 10, 25, 45, as you are observing. And marginal product is then, of course, marginal product delta Q over delta, let's say delta Q over delta, let's say, unit, or let's say here labor, delta labor, you may say. And the total revenue, of course, is going to be then added regarding to this combination, and then calculation, and then marginal revenue then will be then, of course, the differentiation of this will gives us then this, for example, 50 minus 20 is going to 30, for 90 minus 50 is 40, because the unit is 1, 1, 1, 1, 1, then divided 1, then it's going to give again same. 120 minus 90 is going to 30, 140 minus 20 is 20, then it goes like this. As you see here, the red line is representing something that I'm going to tell you. The marginal revenue formula is calculated by dividing the change in total revenue by the change in quantity sold. The marginal delta R over delta Q, which is represented here, and delta R and delta R is, of course, easily calculated from this given. And total revenue is P multiplied Q is given here, the total revenue 20 blah blah. And then the differentiation then will gives you, of course, this marginal revenue, as I mentioned to you. Okay, here the differentiation of total revenue, as I mentioned, will be divided to this total something. And the marginal cost represents the incremental cost incurred when production additional units of a good or services, which is marginal cost is delta C over delta Q. The marginal labor cost is given here. Then of course total labor is 10, 10 divided 10 minus 20 minus 10 is 10, then divided 2 delta Q. Delta Q is the 1 again. Again, 30 minus 20 is 10, 10, then it goes like this. I think there is no problem with these calculations, and I'm going to the next. Production table is given then here, delta Q or delta L, and total quantity divided to labor. This is average. The number of workers is given here, 1, 2, 3, 4, 5. I forget to tell you, this 75, as you see, the total revenue product is reaching somewhere else to the expected, let me say, total cost, 75, 78, it goes. I don't know why it is going to be redlined 75, because it goes up, 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 up. After this, here is going to 20, 10. Well, it is only to represent probably the intersection point of this given formula, I think. Then we go to the next. The number of workers, total output, marginal product, and average product is represented here. As you see, the number of products 1, 2, 3, 4, 5 it goes like this. And total output is then 0, 4, 10, 17 is going. The marginal product, as it is mentioned, delta Q over delta L, which is 4 divided to 1. Then 10 minus 4 is again 6 divided to 1 again. 17 minus 10 is divided 7 to 1 again. It's like this. And average then total Q is this one. 4 divided to L is 1. Then 6. Sorry, this one 10 is divided to is 5. 17 is divided to 3. I think it's 3. Then it goes to 5 point something. Then it goes like this. This is also not difficult, I think, for you. And then production function is again represented here. As you see, the number of workers and the output is represented. As I mentioned to you, this part is very highly increasing the number of workers, and output is very highly increased. And after the second phase, it goes also increasing, but it is decreasing amount of increase realized and reach to the point some optimal, let's say, usage of the workers, and the output is going to be the maximum, and then it goes to negative. And here's again the number of workers, the marginal revenue, and average revenue is represented. And as you are observing here, it is going again, the output increasing, then intersect again the marginal the average. You see, it is intersecting marginal product, the average product. So it is the maximum, then it goes again down. This is the New Testament. Then marginal productivity of labor and marginal productivity of capital, or marginal product, you may say. The rate at which total output changes as the quantity of labor the firm uses is its change. And marginal product of capital, the rate at which total output changes as the quantity of capital the firm uses is change, is supposed to be somehow the productivity. Delta Q or delta L is the productivity. You may say product, but it is the productivity. Therefore, change in total product divided to change in quantity of labor used will give the productivity. And this productivity is the most important parts of the production operation process. Therefore, where you are having the optimal combination and optimal return, this is the best possible combination probably. And for the marginal productivity of capital is also similarly. Delta Q over delta K, or change in total product, will be divided into the change in quantity of capital, will gives you the marginal productivity of capital. And when we are looking to the isoquant example, which is again given, then the production function is again with labor and capital represented. And here the equation is given as O.L, as I mentioned to you in the former example. Capital is 10 and L is 0.1 as assumed. Therefore, 0.1 LK is going to use together, and 3 times L power of 2 multiplied K minus 0.1 L power of 3 multiplied with K, the equation. We assume K is 10, then we're going to put into the equation now this. And then when we're going to put this into the equation, this 10, then we remove K and we are going to represent or interpret the equation only with the labor as it is indicated here. 0.1 L multiplied 10, which is the K, plus 3 L power of 2 multiplied with 10 and 0.1 L power of 3 multiplied with 10. Then this will then gives you L plus 30 L power of 2 minus L power of 3. When you are going to get the differentiation for the marginal productivity of labor, this will then gives, of course, again, the differentiation that I mentioned to you. You know, I think how it is going to be. You're going to reduce 2 minus 1, for example, or 1 L power of 1 minus 1 is going to be 1. Then you're going to remove it from this equation. Therefore, we are going to add 0.1 multiplied 10 is only because we remove this L here. And then you're going to add here 3 times 2, as it is indicated 6 multiplied with 10, because 10 is here. You're going to represent with the L, because L power of 2 minus 1 will gives you the L. And then here 0.1 multiplied 3 multiplied 10, L power of 2, because L power of 2 minus 1 is going to be L power of 2, and 3 is going to be multiplied with 0.1 and 10, which is going to be 1 plus 60L minus 3L power of 2. Where does marginal productivity of labor reach a maximum? To get second derivation, then we're going to use this derivation again. And this will then gives you again once more derivation when we are going to get it. And this will then give you the derivation for the labor. Is going to be 60 plus 6L is going to 0, assumed to be. Then if you're going to add this L to the other side, 6L, then you can represent it easily as 60, or you can say, of course, it should be the absolute value. 6L is equal to 60, and solving for L, we obtain L as 10, because negative values is not considered here. Then we are going to use again the isoquants. Isoquants, a curve that shows all of the combinations of labor and capital that can produce a given level of output. A, B, C, D is given here. As you see at A, we have capital and labor 9 to 5 to capital to labor. At B, 6 to 10. At C, 4 to 15. And at D, we have 3 to 20. Therefore, as you see, when you are going to reduce one of these, this isoquant curve is, as mentioned, it is convex to the origin, and it is somehow reducing the capital to increasing the labor, or vice versa. The linear isoquant curve, the curve shows the perfect substitutes between the factors of production. This means that any quantity can be produced either employing only capital or only labor, or through n number of combinations between these two. Perfect substitutes in production, inputs in a production function with a constant marginal rate of technical substitution. This will then gives you Q is equal to AL plus BK. Linear production function is perfectly substitute supposed to be, as it is given here with the straight line capital to labor, can be, let's say, substitute each other. The fixed proportions production function, a production function where the inputs must be combined in a constant ratio to one another, isoquants for the production of water, where the inputs are atoms of hydrogen, and the atoms of oxygen. Since each molecule of water consists of 2 hydrogen atoms and one oxygen atom, the inputs must be combined in that fixed proportion. The perfect complements, this is then the fixed proportion of the water, which is in the chemistry used. The perfect complements is then inputs in a fixed proportion. Production function is supposed to be perfectly complement, such as CD and CD player, as I mentioned to you in the elasticity. And the right angle isoquant curve, as you are observing here, is represented. This is one of the types of isoquant curve where there is a strict complementary with no substitution. As you are observing, either you are going to use this or you're going to use this and this then direct this as you are observing the straight line coming from the origin. And this strict complementary with no substitution between the factors of production. According to this, there is no, because substitution can be like inverse proportional or inverse relationship between the, but here, as you see, it is when you are increasing one, the other one is going to be increased. Therefore, it is supposed and perfectly increased and enlarged. Therefore, there is no complementary with no substitution, or strict complementary, let's say. According to this, there is only one method of production to produce any one commodity. This curve is also known as Leontief isoquant, input-output isoquant, and is a right-angled curve. In here, it is representing the isoquant curves, as you are observing, where this turns to the very sharp to the inside to become a circulation. This is the uneconomic regions, and where it is becoming the combination of the, or the let's say substitution of the combination like B, D, or F, or E, any. This will then gives the economic region, because this will give them perfect compensation. But when you go here, you see it will then create problem, because you are having somehow isoquant, which is not anymore substitution to other product. Therefore, it is backward bending and it is creating problem. And here it is upward sloping and it's upward bending again, and it's creating some problem for substituting one to another. Therefore, it is supposed to be, as you are observing, because before bending to the inside, then it will becomes probably the optimal combination or optimal substitution zone, as it is represented economically perfect or better zone than the other, let's say, light brown represented zone. A production table is given here, the workers' output, marginal product, and average product. As I have done before, the workers is 1, 2, 3, 4 again, going, the total output is 0, 4, 5, then you did again 4, 4, 4, 4, 6. We did this almost in the former example. Therefore, I may repeat once again, the average product is the output per worker, and marginal product is the additional output that will be forthcoming from an additional worker, other inputs constant. The law of diminishing marginal productivity is then the both marginal and average productivity initially increase, but eventually they both decrease. Marginal productivity labor is delta Q over delta L, and marginal productivity for capital is then delta Q over delta K. The increasing marginal returns to labor the region along the total production function, where output rises with additional labor at an increasing rate, and diminishing marginal returns to labor the regional along the total product function, in which output rises with additional labor but a decreasing rate, and average product of labor, the average amount of product unit of labor, which is Q over L, is supposed to be represented. Then here is then the responding to this event point corresponds to the maximum production efficiency is given here. As you are observing, the marginal product, average product, and the total production is going to be increasing, reaching to the maximum, and goes turn to the negative, and the below it is given the average products, and the intersection of the marginal product of the top of the marginal product is represented. And when we are going to divide these two three phase or three regions, the first region is supposed to be increasing yield and point of inflection, as it is represented here, as I mentioned to you. And this is then the irrational is supposed to be elasticity is higher than 1, is risky. And the rational is where the elasticity is between 0 to 1, where it is inelastic, and decreasing yield supposed to be is somehow reaching to the elasticity 0, and here the elasticity is unique, is 1, and then it goes to be the irrational region, where elasticity is less than 0, and it is somehow negative yield subjected. When average product is increasing in labor, marginal product is greater than average product. That is, if average product labor to labor is increases in labor, let's say, then the marginal product is becoming higher than the average product. When average product is decreasing in labor, the marginal product is less than the average product. That is, the average product to labor decreases in labor, then the marginal product is supposed to be less than the average product as a subjected to the labor. And when average product neither increases nor decreases in labor, because we are at a point at which average product to labor is at a maximum, then marginal product is equal to average product. So called the marginal productivity of labor is going to be equal to average product to labor as it is represented here. Okay. The law of diminishing marginal productivity, this means that initially the production function exhibits increasing marginal productivity. The marginal productivity to labor is then delta Q over delta L, or marginal productivity to capital is then delta Q over delta K. Then it exhibits diminishing marginal productivity, and finally it exhibits negative marginal productivity. The law of diminishing marginal productivity, the most relevant part of the production function is that part exhibiting diminishing marginal productivity. As I mentioned to you, delta Q over delta L is the marginal productivity to labor, and delta Q over delta K is the marginal productivity to capital is going to be estimated. The law of diminishing marginal productivity, as more and more of the variable input is added to an existing fixed input, after some points, the additional output one gets from the additional input will falls, as you are understanding it is in the denominator position. Therefore, as much as you are increasing the fixed amount of input, this will then negatively affect, of course, the proportion. Therefore, when we are going to flashback again, the law of diminishing the marginal productivity, again the same example, the increasing marginal return as it is represented here, 4 to 5 somehow, and then here it is diminishing as you are observing after 8, 7, 8, 5.8, then it goes to 5.6, 5.2, 4.6, and diminishing absolute returns, then it goes to 4, 3, and it is enlarge and increase heavily. Therefore, this is important to know. We have to determine what is the expectation of this firm, whether it is going to get the best possible combination for the productivity, or it is trying to get and capture more market by enlarging and increasing the amount to produce goods and services in the market for becoming more dominant position, while the diminishing returns is increasing, but somehow it is a little bit increasing and enlarging the market structure. Or you're going to determine, of course, when you are going to diminish your absolute returns heavily. Here represents on the graph, as you are observing, this is increasing, as I mentioned. This is then diminishing marginal returns as you go, as it is represented and explained before. And this is then goes to negative. And as you are observing, when we are going to represent the tables or graphs on this slide, there is average production and marginal production again. And as you are observing, the diminishing marginal returns is of course, the point where the marginal productivity intersect the average productivity at maximum point. And this has meant there is, of course, at that point, negativity. As you are observing, the average productivity is going negative, and marginal productivity is intersecting always at that point. And this has meant the marginal productivity, when it turns to negative, then this is the indication that you are in diminishing and you are decreasing your performance, your productivity. And somewhere else, when it is intersecting the average production, this will then cause some negativity to the economically of this business. The graphing the production function again here is represented increasing marginal productivity in the first phase, where 1 to 2 to 3 somehow, and diminishing marginal productivity where it is 3 to 7 is realized. It is somehow increasing a little bit, that it is decreasing amount of increase realized somewhere else at some 5 or 6 somewhere else around here. and then diminishing absolute returns, then it goes to maximum, then turns to negative. Therefore, production function is the relationship between the inputs and the outputs. As you are observing, as much as you are increasing the number of workers, the productivity of these workers is increasing, but it is proportionally decreasing. You have the same amount of increase, let's say 100 workers, 200 workers, 300 workers, but its contribution as an output, as a productivity, or as GDP is decreasing. As you see, from 2 to 8, it is 6 units. From 8 to 14, it is somehow again 6 units, but from 14 to 20, again somehow 6. But this manages to decrease not similarly as it is proportionally represented, because you are observing when you are going to 2, it is somewhere else here, isn't it? When we are going to 2, it is here. When you go to 8, somewhere it is here. When you go to 3, it is somehow 9. When you go to 4, it is somehow, let's say, 14. When you go to 5, it is somehow, let's say, 20. When you go to 6, it goes to 26. When you go to 7, it goes to somehow 30, some 32, but it is decreasing in the percentages of the contribution because it is enlarging. This is not very, let's say, uh, it somehow becomes more flatter comparing to this period of time. As you are observing, steadily becomes more flatter to the x-axis, and it is not anymore stepper to the origin. In the beginning phase, it is more stepper, and it goes steadily to flatter and enlarge and becomes to the, let's say, parallel to the x-axis, and where it is the negative turns. And here again, the increasing area, diminishing returns here is represented with the orange one, and black is the absolute productivity where it turns to negative. The marginal productivity goes to negative, and average productivity is, of course, from the midpoints after this intersection is already in the negative. Therefore, the marginal productivity is negative as much as when you are enlarging and trying to increase your production. It is not giving you more chance to resist the shocks or resist the market, let's say, rivals where it is stronger than your capacity or your, let's say, business. Here again, the workers, total output, marginal product, and average product is given. As you are observing, similarly, the same example, we are continuing. The numbers here, law of diminishing marginal productivity states as more of variable inputs is added to the existing fixed input, after some points of the additional output from the additional input will falls as it is represented here. As you see, as I mentioned to you, it was the average product and the marginal productivity also, as you see, 4, 6, 7, 6, 5, 3, and it goes down, as I mentioned to you. And here it is 4, 5, 5, 7, 5, 8. As you see, after 5, 8, and it turns to negative to 5, 6, 5, 2, blah, blah, and it goes down. Therefore, this is diminishing marginal productivity. And after this black, then it is then absolute diminishing productivity region is represented. The law of diminishing and marginal productivity is, this is then there, of course, law is called as the flower pot law. And if it did not hold true, the world's entire food supply could be grown in a single flower pot, which is not possible. Therefore, diminishing marginal rate of technical substitution, a feature of production function in which the marginal rate of technical substitution of labor for capital diminishes as the quantity of labor increases along an isoquant, and marginal rate of technical substitution is equal to marginal productivity to labor divided to marginal productivity to capital, which has meant delta Q over delta L divided to delta Q over delta K is equal to delta K over delta L, because you're gonna eliminate the delta Q's from this equation. And then when we are going to the elasticity of substitution, which is very important, the elasticity of substitution measures the percent change in the capital labor ratio for each 1% change in the marginal rate of technical substitution labor to capital as you move along the isoquant, as I mentioned to you. Isoquant is the combination of two labor and capital, best possible option. and the quantity or the production function is going to be represented as quantity is equal to L power of 5 and K power of 25. Therefore, marginal rate of technical substitution, then marginal productivity labor to marginal productivity capital is going to be calculated by taking the differentiation of this given example, which we are not going to use, and a measure of how easy it is for a firm to substitute labor to capital ratio. It is equal to the percentage change in the capital labor ratio for every 1% change in the marginal rate of technical substitution of labor for capital as we move along an isoquant curve. As I mentioned to you, it is something like a curve, a convex curve to the origin, and as much as you move along this curve, you're gonna substitute either capital or labor each other, which will give you the same or similar combination. The elasticity of substitution between the inputs, then we are going to use for this elasticity equation, delta Q or percentage delta K over L will be then marginal or delta marginal rate of technical substitution is going to divide it. And then we are going to put this into the equation, delta K over L divided to K over L will be then the differentiation of the delta marginal rate of technical substitution to the marginal rate of technical substitution. This will then gives you delta ln KL, for example, if it is in the ln form, divided to the delta ln marginal rate of technical substitution. If it is in the example given, then you will use, but we don't use it. We're just going to use and introduce you the elasticity, how it is affecting and changing the substitution in the inputs. And inputs are supposed to be perfectly substituted if the elasticity is infinitive, and inputs are perfectly complement if the elasticity is 0. And lower elasticity means it has a harder to substitute K for L and vice versa, and higher substitution or elasticity means it is easier to substitute K for L and vice versa. Note that elasticity is units free. Of course, we mentioned. Calculating elasticity of substitution example, consider a production function whose equation is given by the formula Q or quantity is equal to root square KL, which has corresponding marginal productivity. The marginal productivity to labor then will be 1 over Q. This is then the simplest differentiation formula for the labor or capital we are using, as I have mentioned in the utility function. Marginal productivity to labor will be then 1 over 2 divided 1 over 2 is of course is in the division or in the denominator will be then root square K divided to L, and the marginal productivity K is then 1 over 2 root square L, because we are taking the K is in the root square, of course, and K is in the denominator. Show that the elasticity of substitution for this production function is exactly equal to 1, no matter what value of K and L are. Let's see. The marginal rate of technical substitution LK is the marginal productivity 1 to marginal productivity capital. As I mentioned, marginal rate of technical substitution is the productivity differentiation. We did as it is given in the former slides. 1 over 2 divided to 1 over 2 root square K divided to L, and 1 over 2 divided to 1 over 2 root square divided to K, and simplified to sigma indicates, of course, percentage of delta K over L divided to percentage differentiation of the marginal rate of technical substitution labor to capital. Since the marginal rate of technical substitution for labor to capital then will gives you then K over L, it follows that the percentage, since then using the definition of the elasticity of substitution, it follows that the diminished differentiation of the marginal rate of technical substitution labor to capital will be exactly equal to differentiation of the capital to labor in a percentage, of course. This means the differentiation of the marginal rate of technical substitution labor to capital is equal to capital labor ratio, and this is then the differentiation of capital to labor or capital divided to labor, and the percentage differentiation marginal rate of technical substitution labor to capital is equal to percentage differentiation capital to labor. Therefore, this is of course the easiest example that we can give you. And then returns to scale for a Cope-Douglas production function. When we are going to flash back to the Cope-Douglas production function, I think you know this Cope-Douglas production function, a production function of the form where A is the, Q is supposed to be A is the available technology or available something or any constant, labor alpha, K, or capital beta, where Q is the quantity of output from L units of labor and K units of capital, and where A, alpha, and beta are positive constant. As I mentioned, it can be the technology, and these are the, of course, power of, let's say, labor and capital, and alpha and beta has also means something that I'm going to give you also this. The combination of alpha and beta must be equal to 1 or smaller than 1 or higher than 1 has meant for this Cope-Douglas. Let's see in the following slides. Returns to scale, the concept that tells us the percentage by which output will increase when all inputs are increased by a given percentage. Return to scale, as I said to you, it gives more option to the firm to create and enlarge their production operation process. Therefore, return to scale is then the change quantity of output divided to change in quantity of all inputs. This should be in the other side actually, but it's okay. And here, alpha and beta, if it is more than 1, increasing returns has meant for the Cope-Douglas. I'm talking about this alpha plus beta in the Cope-Douglas function. Increasing return to scale, a proportionate increase in all inputs quantities, resulting in greater than proportionate increase in output, and alpha plus beta, if it is less than 1, decreasing returns to scale, a proportionate increase in all inputs quantities, resulting in a less proportionate increase in outputs, and alpha plus beta, if it is equal to 1, it is then constant return to scale, a proportionate increase in all input quantities simultaneously that results in the same percentage increase in output. Example, problem, does a Cope-Douglas production function Q A L alpha K B exhibits increasing, decreasing, or constant returns to scale? Solution, let's L1 and K1 denotes the initial quantity of labor and capital, and let's Q1 denotes the initial output. So quantity A alpha, L power of alpha and K power of beta. Now let's increase all input quantities by the same proportion amount lambda, where lambda is higher than 1, and let's Q is denotes Q2, of course, denotes the resulting volume of inputs. Here it is then represented again, the Q2 is equal to alpha in the bracket lambda L1 power of alpha close and multiplied with lambda K1 power of beta is equal to lambda alpha plus beta L1 power of alpha and K1 power of beta is then lambda alpha plus beta, which is then L and K is then Q. From this, we can see that is alpha plus beta is higher than 1, then lambda alpha plus beta is higher than also from lambda, and so Q2 is higher than lambda Q1, increasing return to scale, or alpha plus beta is less than 1, then the alpha plus beta in lambda is less than lambda, and then so Q2 is less than also lambda Q1, decreasing return to scale, and alpha plus beta is equal to 1, then alpha plus beta, sorry, lambda alpha plus beta is equal to lambda, and so Q2 is equal to lambda Q1 constant return to scale. This is, of course, imaginary given numbers and example for you to understand how the Cope-Douglas function affecting, or the Cope-Douglas this alpha beta affecting and changing the function of the Cope-Douglas. Cope-Douglas return to scale. This shows that the sum of the exponents alpha and beta in this Cope-Douglas production function determines whether returns to scale are increasing, constant, or decreasing. For this reason, economists have paid considerable attention to estimating this sum. If it is more than 1, then it says it is increasing. If it is less than 1, it says it is decreasing. And if it is equal to 1, then it says it is constant return satisfied. Therefore, only these exponents or these alpha and beta coefficients or numbers or the, let's say, exponents are representing the function's direction. This was the today class. I will finish here our period and semester. This is the summer, this is the spring semester, and period is over. We have next week, after the next week, I think we have the exam at 13th of June. It is fixed and is not possible to change because I have some other students from the industry, they are working, and we fix it regarding to their permissions. And you will find this file also in YouTube as a video, and you will find in Q's as a PowerPoint slide. And if you have any question also, you will ask me via WhatsApp or via email. And for your exam, I wish you the best. I have some questions for you presented in the form of calculations and in the form of some test, I think. I don't know whether it is test, but I have some questions for the class, for the theoretical parts, and some questions for the calculations, the utility, consumer preferences, elasticity. These things will be asked to you in the exam, and also some questions from the production cost. Maybe I will give you some test questions. If you have any question, you ask me. If not, then I will stop here, and you will study this, and you will exercise. It is not difficult. The production function really very easy, I think, for you, because the utility function is a little bit complicated for you, that I excluded many things just for summarizing you because of your differentiation problem. I excluded this some parts of this utilities, but I think you will understand better when you go to study and learn better, because only watching videos and listening my let's say presentations is not enough. Of course, it is good to listen. It will help you to understand better, but you have to read, flashback to the videos also in the YouTube. Listen, stop and listen, go back and listen again and again. Then you will understand what has meant, because we are in a limited time, in 1 hour, in 1.5 hours. So you have to slowly stop and listen and take notes, and you will understand better, I think. Do you have any question? As I said to you, the assignment is already uploaded. If there is anything, something, then you contact me, then I will check, because I don't know, I was quickly done. Maybe something is open, but I don't know. I will check, or let me check what you are requesting, then I will reply you. Okay, you write me email, I will check, then I will reply you. If it is done, then I will correct it. If not, then it's okay. If you have any question, you ask me. Yes, please.
Yes, just one question about assignment. I don't think that the email will be quite relevant for this kind of question. Can you just open the document?
Which question you are talking about?
The question assignment number 2 question, like the solution part. Question C.
Which one?
C.